Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we're looking at lesson 109 in the edition 2 Saxon Blue Book, and lesson 68 way back there in edition 3. So here on this one, it's a little bit out of order between the two, but hopefully you can find it, even though I put them in order according to the edition 2 because that's what I have. So you will be able to search it though with the edition 3 mark there. So I'm trying to label everything so that you can find everything. So here we're doing percent word problems, which is one of my favorites. 20% of the clowns had red hair. If 40 clowns had red hair, how many did not have red hair? They do not tell us the number of clowns we have total, but we know that we're talking about a total population of clowns. Okay, so clowns is our 100%, and that is our before number. And then we're going to take 20% had red hair, and then 20% plus 80% gives us our 100%. So 80% did not have red hair. Okay, so then they give us one more piece of information. We're always going to draw a diagram because the diagram is going to make the picture, the problem so much clearer. So 20% of the clowns had red hair, 20% had. If 40 clowns had red hair, that is the 20%, isn't it? So 20% was 40. And so now we can't figure out what the 80 is because we don't know how many clowns we have. But we do know something. Now we know that 40 is 20% of means times, total number of clowns. Okay, so 40 is the 20% of the clowns. So we can put our equal where the is. And then we have 20% is 0.2. So we're going to divide both sides to get the C. Aren't we going to divide by 20% and divide by 20%? So let's do that math. We're going to say 40 divided by 0.2. Okay, so let's just come over here. 40 divided by 0.2. Remember, 0.2 is 20%. Now that's hard because the decimal's still in the denominator. But if I slide the decimal 1 and I add a 0, I get 400 divided by 2. So I have 200 total clowns. So once I know that my total clowns is 200, and I know that 40 of them had red hair, then 200 minus 40 has to be the remainder. Okay, now your book puts what number here? Okay, what number of clowns had no hair? Had no red hair. Okay, so we're going to say 200 take away the 40 is 160. 160 clowns had no red hair. Now we could check by saying what is 80% of 200, and 80% is 80 over 100. So the 100 on the bottom and the 200 on top will cancel, leaving 2 times 80, which is 160. And it works. So 160 clowns had no red hair. Okay, so this is our second example. When the fog lifted, the number of frogs that could be seen was 140% greater than before the fog lifted. If 40 frogs could be seen before, how many could be seen after the fog lifted? So here is our problem. And remember, we're going to call whatever happened before the 100%. So here is our picture, our little diagram. So there were 40 frogs before the fog lifted that could be seen. So of 40, we're going to call 40 the 100%, and it's our before number. And then after the fog, there were 140% more frogs. Well, 140% added to the 100% that was already there because it said 140% greater than that. So it's really 240% of whatever number we're talking about. So the 100% was the 40, and now we're talking about the 240%. So if 100% was the 40, that was the before number. So now we're going to take 40 and multiply it by 240%. And so we have 40 times the 240%, because that's the 140 greater added on to the 100%. Then we have 40 times 240 over 100, which is the same thing as 240%. Now look what I can do. I can cancel the zeros right there. And then I have a 10 to cancel with the 40. So then we'll cancel the remaining 10 with the 40. So I end up with 4 times 24. And 24 times 4 is 16 carry 96. So 96 frogs could be seen after the fog cleared. Okay, so here we have the next example. 40% of the trees were in bloom. If 1,200 trees were not in bloom, how many trees were in bloom? So one thing we don't have here is we do not have the 100% given to us, do we? We don't know what the 100% is. Now we do know here that we have 40% of the trees were in bloom. Okay, and then that would mean that we would have 40 from 100 would be 60% of the trees would not be in bloom. And we know that 1,200 trees were not in bloom. So 60% of all the trees were equal to 1,200 trees. So we know that. And how are we going to find out this right here? So this is the number we're looking for. How many trees were not in bloom? So we actually never have to figure this one out, but we will figure it out because we need to know the total number in order to know how many were not in bloom. Okay, so we're going to say 60% of all the trees, the total number of trees, is 1,200. Okay, because we know that the 60% equals 1,200. So now remember the 60% is the same thing as 0.60 times the number of trees. We're trying to find the total number of trees. So we can put it here. Then we can subtract the total minus this to get this. Okay, so we have 60% times all the trees gives me 1,200. I'm going to divide this side by 0.6, and I'm going to divide this side by 0.6. Remember, that's going to cancel, right? Because that 0 right there makes no difference. So now we have t is equal to this. Remember, we have to clear this decimal by moving it one place to the right and tacking on another 0. So now we have 12,000 divided by 6, which is going to give me 2,000 total trees. So 2,000 total trees, okay? And let's check. What is 60% of that? So that would be 2,000 times 0.6. Let's just do it right here. Okay, and that's going to wind up giving me the 12 and then one less 0 because of the point there. So it is to the 1,200, isn't it? We're just checking our math. So now that we know the total is 2,000, we can take away the 1,200 and get 800 must be in bloom. And that is your problem. Let me see if I can get it all there so that you can get anything you did not already have. Here's our first practice problem. 30% of the trees had red blossoms. If 600 trees had red blossoms, how many trees did not have red blossoms? So here we have a percentage that is equated with the same number. So here we have our total, and we don't know how many we have in our total. This is our 100%. We don't know how many trees there are, or it would be very easy to do, wouldn't it? But we do know in our little partial egg over here that we have 30% that have red blossoms. Okay, 30% of the total number of trees. And then we have 600 trees that do have the red blossoms. Now down here, they don't have the red blossoms. Okay, we know that this is 70% of this number because 30 plus 70 equals the 100%. And we don't know what this is. So how many trees did not have the red blossoms? Now we're going to have to figure out this in order to figure out this. So we're going to say 30% of the total number of trees is 600. So that will be our equation. So here's our board. 30% of the total number of trees is 600, just like we said. So now the 30%, isn't that the same thing as 0.30? So now we're going to divide this side by 0.30, or 0.3, divide this side by 0.3. They're the same. So now these cancel, and we get the total number of trees is 600 divided by 0.3. So let's run our decimal, 1 to the right, and our decimal, 1 to the right, is adding a 0 on the top. So 6,000 divided by 3 is 2,000 total number of trees. Okay, so now in this board, we now have this number. 2,000 is the total number of trees, and 2,000 take away the 600 is going to leave 1,400 trees that do not have the red blossoms. So 70% of 2,000, remember this is a 0.7, and 0.7 times the 2,000 is going to drop 1 0 and make that a 14. So 1,400 is correct, and 1,400 is our answer. So that one was your practice, and I forgot to tell you to pause your video, didn't I? Uh-oh. Here's our last problem. So we have James found that the glob increased from 400 pounds to 640 pounds in just 3 hours. What was the percent increase in the weight of the glob? So the 3 hours there is just kind of a tricky little distraction, isn't it? We're not really asked anything about the 3 hours. So James found that the glob increased from 400 pounds to 640 pounds in just 3 hours. What was the percent increase in the weight of the blob? Now, this problem right here, we can do with our percent increase formula. And remember, percent increase or percent decrease is difference between the two quantities divided by the original. And you can always use that when you have percent increase or percent decrease. So go do that one and come back and check your answer. So pause your video. So now all we have to do is take the difference between them and divide by the original, which was what it started to be. So we're going to take the difference, which is 640 minus 400, which is 240, and we're going to divide the 240 by the 400. Okay, so 240 divided by 400, 240 divided by 400, we cancel the zeros, and we can divide by 4. So divide that one by 4, divide that one by 4, and we can divide by 2 again and get 3/5. So 3/5 is a good fraction, but we wanted a percent increase. Okay, so we found the difference and then we divided over the original. So this is percent increase, but it's not in the right form. So we're going to go ahead and put it in the 6/10ths form and make that 0.6. Turn it into a decimal. It's easier to turn into a percent. And then to turn it into a percent, we're going to move our decimal 2 places and stick the percent sign on. So there was a 60% increase. And that is all of our work today in this lesson. And this is Mrs. A, and may God bless your day.